Welcome to PRISCI-ANTO Educational Academy. Today we are going to study about the binomial distribution. Bi means two, success, failure, defective, non-defective, male, female, hit the target, not hitting the target. Okay, so receiving the signal, not receiving the signal. So these will come under the binomial distribution. So there are two parameters in the binomial distribution. Binomial distribution is discrete distribution. There are two parameters, n and p. In probability, p plus q is equal to 1. P plus q is equal to 1. So here, the binomial distribution definition is probability of x is equal to x, which is equal to ncx, p power x, q power n minus x, comma, x is equal to 0 to n, 0, 1, 2, 3, up to n. Okay, so ncx means combination. You can write as n factorial divided by x factorial into n minus x factorial. P is we can take as success, q is we can take as a failure. So you know this, n is number of samples, right? So n and p are the parameters. Let us see the derivation of moment generating function as well as mean variance. In the next video, we will I'll explain you about the problems in binomial distribution. So moment generating function. The moment generating function is denoted by mx of t, which is equal to expectation of e power tx, which is equal to summation of e power tx into p of x. This is the formula, summation e power tx into p of x. What is the p of x? That is the binomial distribution definition. Already we studied p of x is equal to x, which is equal to ncx, p power x, q power n minus x. So you have to write for p of x, ncx, p power x, q power n minus x. So summation x is equal to 0 to n, e power tx, ncx, p power x, q power n minus x. So in the next step, p power x, first term is e power tx. So both are having x. So you can write the power x, you can write as a common. So summation x equal to 0 to n, ncx, p e power t, because of p power x, e power tx, both can be written as p into e power t power x into q power n minus x. Now we are going to apply for x 0 to n. So first we will apply for x 0, nc 0, p e power t power 0, q power n minus 0. For x is equal to 0, we have applied. So next, plus. Why we are writing plus? Summation symbol. That's why we are writing plus. Suppose if there is a product symbol, pi, that is the for product. So this is a summation. So we are writing plus nc1 for x equal to 1. nc1, p e power t power 1, q power n minus 1 for x is equal to 1. Next, plus. For x equal to 2, you have to apply nc2, p e power t power 2, q power n minus 2. In this way, if you are continuing like this, finally we will write for x is equal to n. So plus ncn, p e power t power n, q power n minus n. What is the nc0? 2c0, 1c0, 3c0, nc0, the value is 1. Anything power 0, p e power t power 0, value is 1. Q power n minus 0, n minus 0 means n. So q power n. So first term will become q power n. plus NC1 P e power t power 1 Q power n minus 1 plus NC2 P e power t power 2 into Q power n minus 2 plus etc. plus the final one NCN. NCN will become 4C4, 1C1, 2C2, 3C3. Value is 1. NCN value is 1 into P e power t power n. Q power n minus n. Q power n minus n. Q power 0. Q power 0, 1. So 1 into P e power t power n will be plus P e power t power n. This looks like the binomial theorem x plus a whole power n, which is equal to x power n plus nc1 x power n minus 1 into a plus nc2 x power n minus 2 into a square plus nc3 x power n minus 3 into a cube, okay, plus etc. plus a power n. So in this way, so we are using the binomial formula. First term is q power n. Last term is P e power t power n. So both you have to add. So mx of t moment generating function is q plus P e power t whole power n. So this is moment generating function. So there are two ways to find the mean and variance of binomial distribution. What is the two way? One is you have to differentiate with respect to t at t equal to 0, the moment generating function. If you are differentiating moment generating function with respect to t at t equal to 0, you will get a mean. Again, if you are differentiating, two times if you are differentiating, you will get e of x square. Two times if you are differentiating the moment generating function at t equal to 0. This is one of the way to find mean and variance through moment generating function. Without using the moment generating function, you can also find the mean and variance. How to find the mean and variance? Mean E of x is equal to summation x into P of x. E of x square is equal to summation x square into P of x. In this way also you can find. But I used the method, the moment generating function. I am going to differentiate moment generating function. So that's why I am writing here the formula mean and variance of binomial distribution. Mean is equal to E of x is equal to summation x into P of x. D by dt of, this is another method, mx of t at t equal to 0. What is mx of t? D by dt of q plus p e power t whole power n at t equal to 0. You know very well the formula d by dx of x power n is equal to d by dx of x power n is equal to n into x power n minus 1. So q plus p e power t whole power n, if you are differentiating, n you have to write first, n into q plus p e power t power n minus 1. X power n can be written as n into x power n minus 1. Q plus p e power t power n can be written as n into q plus p e power t power n minus 1. Into, next you have to differentiate the base. Power is n. So power n we have differentiated. Next you have to find the base. Which one is the base? Q plus p e power t. That is the base. Power is n. So q plus p e power t you have to differentiate with respect to t. Q is not having t. So q, if you are differentiating with respect to t, 0. P e power t. P as it is you have to write. If it is in the multiplication, e power t, if you are differentiating, e power t will come. So that's why I have written here n into q plus p e power t power n minus 1 p e power t at t equal to 0. So if you multiply np e power t q plus p e power t power n minus 1 at t is equal to 0. This value is one time we have differentiated. So when we are going to find the e of x square, how to find? Two times you have to differentiate moment generating function. But one time we have differentiated here, the shaded. One time we have differentiated. So in E of x square, in finding E of x square, you have to use this value and differentiate this value one time. Okay, that is equal to 2 times differentiating of moment generating function. Okay, so at t equal to 0, here t is equal to 0, you have to apply e power 0. np e power 0 will be 1. np e power 0, 1. So np. Q plus p e power 0. What is e power 0? 1. So q plus p. In the starting, what I told, q plus p is equal to 1. P plus q is equal to 1. So 1 power n minus 1 will be 1. So 1 into np is equal to np. So expectation of x is equal to np. Next, we have to find the n e of x square. 2 times you have to differentiate mx of t, moment generating function. You have to differentiate 2 times, but it is n of, already we have differentiated here. So it is n of 1 time. If you are differentiating this value, you will get the value of e of x square. Okay, so I am writing here 1 time. I am taking differentiation here, d by dt np, the value in e of x I am writing here e power t q plus p e power t power n minus 1 at t is equal to 0. Now we have to use, okay, so np, there is no t, so I have taken as a common, so np into d by dt of e power t into q plus p e power t power n minus 1 at the point t equal to 0. So I am going to use differentiation of uv formula. U is e power t, v is q plus p e power t power n minus 1. What is the d of uv? U dv plus v du. D of uv is equal to u dv plus v du. So u is e power t, v is q plus p e power t whole power n minus 1. What is the u dash? U is equal to e power t. If you are differentiating it, u dash, which is equal to e power t. If you are differentiating, you will get e power t. Next, v dash. So this one is, you have to differentiate v n minus 1 into q plus p e power t power n minus 2. So after that n minus 1 you have to forget. The base you have to differentiate. Q plus p e power t is the base. Base if you are differentiating, q if you are differentiating, because it is not having t, so 0. P e power t will be p e power t. P plus q is equal to 1. You have to keep these all in your mind. So using the formula np into e of x square, np into d by dt of e power t q plus p e power t power n minus 1 at t equal to 0. So we have written everything. U dv plus v du. So np u dv e power t, dv is, okay, v dash, dv is v dash, n minus 1 into q plus p e power t power n minus 2 into p e power t plus u v dash plus v u dash. V is q plus p e power t power n minus 1 into u dash is e power t. Now at t equal to 0, np e power 0 value is 1, q plus p e power 0 value is 1, q plus p value is 1, 1 power n minus 2 value is 1. So n minus 1 into p into e power 0 value 1. So p into n minus 1 or n minus 1 into p. np into n minus 1 into p plus e power 0 1, q plus p e power 0 1, because q plus p also 1, 1 power n minus 1 1, 1 into e power 0 1. So 1 I have written. For t value 0 substituted, np into, you have to multiply np minus 1 into p minus p plus 1. Now you have to multiply each term with np. np into np, n square p square. np into minus p minus np square. np into plus 1 np. So e of x square is equal to n square p square minus np square plus NP. This is E of x square. As usual, we know very well, variance of x is equal to E of x square, expectation of x square minus expectation of x whole square, which is equal to, you have to write first the expectation of x square, n square p square minus np square plus np minus E of x whole square, expectation of x whole square. Expectation of x is np, so np whole square, which is equal to n square p square minus np square plus np minus np square. Minus np whole square is n square p square. First term, last term will be 0. If you are adding, will be 0. So second term, third term will come np minus np square. Np, if you are taking as a common, np into 1 minus p. So what is 1 minus p? That is q, because p plus q is equal to 1. Q is equal to 1 minus p. So np into 1 minus p, np into q. For 1 minus p, you have to write q. So npq. So variance is npq, mean is np. Okay, so variance, mean is np, variance is npq. So this is the derivation of binomial distribution, mean and variance. Thank you.